Hi, I'm Anton Smith, Director of Product Management at Spectro Cloud. Today I'm going to talk to you about physical security at the edge. That's when you're going to deploy tens, hundreds, or thousands of these little guys all over the place, and you want to make sure that there's no tampering or theft of data. And physical security is extremely difficult at the edge, as we know. So let's just dive straight into it, shall we? As I mentioned, edge devices are extremely physically vulnerable. They pass through logistics supply chains, they go through delivery vans, they're in sites and locations where you simply can't guarantee their physical security. And this is a real problem for customers. You don't want someone to just pick up the device and pull data off the hard drive. You don't want people to impersonate your devices and join your network. And you don't want people to tamper with your devices so that they can gain control over them and then snoop and exfiltrate data over time. So how can we deal with this basically scary problem? Well, Spectro Cloud Pallet Edge has the perfect solution in the form of our Secure Edge Native Architecture, or SENA. This is specifically designed to protect against tampering and device impersonation, as well as data theft. And this is enabled through three core components and capabilities: hardware root of trust and trusted platform module, trusted boot, and encryption or full disk encryption. And we're going to go into the details now. Okay, so let's talk about the hardware root of trust and the TPM first. What are they exactly? Well, hardware root of trust is basically saying, I need something on the box in the hardware that I can always trust and that always starts first on the system when you turn it on. There's no way to tamper with it, and this thing can essentially start the entire chain of understanding and measuring and testing everything that comes after it. The TPM, the Trusted Platform Module, is a special chip that is designed so that you can't steal secrets from it, so you can store secrets in it, and you can ask it to do certain cryptographic operations, as well as being able to measure certain things about the entire box and the things that are happening during the boot process. You can think of the TPM and the root of trust as working together. The TPM is kind of like a special observer, seeing what's going on everywhere, as well as storing information about what it sees, storing secrets, and being able to respond to questions. These questions are like, can you please prove to me that you are who you are? Now, of course, there are some assumptions here. I have to be very careful. This all relies on the vendor of your hardware also being trustworthy, so you need to make sure that you pick somebody well-known in the marketplace and well-trusted. So this root of trust in the TPM enables us to do cool things like what I'm going to come to now. Let's start with trusted boot, because this is my favorite part. It works because of the TPM and the firmware working together. And the firmware is only going to boot what is called a signed image, so signed software. And what that means is some type of operating system or image that you've built using our EdgeForge framework that you have decided you want those boxes to boot, and you don't want them to boot anything else. So the firmware will basically check the signature of those images, and it will say, nope, not trusting that, or it's all good, I'm going to do that. Now, the TPM is kind of like the observer watching the firmware, because you can actually mess with the firmware and tell it to load some other type of signed software, perhaps your malicious software. But the TPM is watching this and says, nah, actually the firmware doesn't look like what I expect it to look like, and it's not trusting software that I would think it should trust. So trusted boot basically means nobody can tamper with your boxes in order to get them to boot something strange and load some other operating system. And even if they physically get the box and try to mess with the firmware, it's just not going to work because the TPM is going to know all about it. And that takes us to the next step in the process of securing everything, which is encryption. And encryption is important because even with trusted boot and not loading any malicious software, you still need the data on the disk to be encrypted so that if somebody steals the device or steals the disk, they can't just literally copy the data off the disk. So there's a very important binding here between the TPM, the signed software, and the trusted boot process, and the decryption part. Remember, I've spoken many times about how the TPM is actually observing everything. Now, the TPM is also the thing that is going to have the key for unlocking the disk or the partitions on the disk. And it will not give out that key unless it thinks that everything has gone according to plan. So if even the tiniest bit or byte has changed, someone has tried to change the firmware, someone has changed the operating system that the device is booting, the TPM is going to say, nope, you are not getting the key to decrypt the sensitive data on this drive. And this is very powerful because at that point, the device is basically unusable by anybody. Sure, they could have loaded it and they could run something of their own on it, but then all they've actually stolen is the device itself. So you can argue that that is useful for them. However, if their intention was to steal your data or impersonate your device, then it is not possible for them. One final thing, disk encryption itself also helps prevent tampering. There's no way for people to mess with the encrypted disk in order to try to insert some type of malicious software or start snooping that way. If they make any changes to the content of the encrypted partitions or the disk, it will simply become corrupted and it won't be usable anymore. So again, no matter what people try to do to try to gain access or insert anything here, the device will, with your data, will essentially become unusable. Now, of course, Spectro Cloud Palette Edge supports all of this capability, but we have something even more just to add another layer of security to encryption. Not only that you can't separate the disk from the TPM or edit anything on it, but you can't even take the device away from the network because we have something called a network challenge service. And this means that as part of decrypting the drive, it actually has to reach out to something that's only present on your network. And if it can't find it because you stole the device and you took it home or to some other place for looking at it, it simply won't work. So again, only with Spectro Cloud Palette, an additional layer of security that is very important. Okay, so we've spoken about the problem. Basically, physical security is hard. There is none. Well, there might be some, but you never know. It could be in all sorts of locations and it's passing through all these different logistics chains, etc. It's frankly a nightmare. It necessitates a solution like Spectro Cloud Edge and our SENA architecture. Using things like the TPM, the trusted boot, and encryption, we can essentially lock down devices so that they're tamper-proof and so that they are extremely resistant or it's impossible to alter their configuration and steal data. Now with Palette, Kairos, our open source project which underpins our Edge offering, and EdgeForge, which enables us to customize builds and configurations of your Edge deployments, we provide the full capability for you to deploy what you need, but still retain full security and giving the ability to sign and manage your own images, but in an easy to operationalize way. Well, that's it for today. If you want to know more, go and get our SENA white paper. It's fantastic. It has so much detail, much more detail than I can cram into this video alone. Also, come and join us on our community Slack. We would love to start talking to you. Ciao.